So, you have an equation here. If I covered up the x squared and made it negative 2x minus 24, you could solve for it, right? Hopefully. Add 24 over, solve for that. Okay? And to solve for it, that means you'd find a solution of x where if you plugged it in, it'd make it 0 equals 0 and things would match. So what I want you to do is I want you to figure out what the solutions are for that equation. We don't really have a way to solve it. So why don't you just pick some numbers, plug it in, and see what we get. Just plug in some numbers.
And you had to get all mathematical over here and use big words, and I solved it, and you just keep using them. Winner.
You're picking numbers to plug in, guys. Don't sit there and wait. Pick a number, plug it in, see if it works. If it doesn't work, pick another number. You can just quickly do it in your head off to the side. I just want you to try some numbers. Don't sit there and wait for someone else to do it. You do it. Okay, how many? I don't want to know the number. Don't say the answer, but how many have found one answer that works? Okay. Do you think that's the only answer? Oh, so maybe we should try some other things. Great idea. Okay, let's pause here. Let's take a different approach. We said some of you found an answer. What is one of the answers you found? 6. Fantastic. Anybody find an answer that was not 6? Negative 4? So we got 6 and negative 4. You want to check negative 4, see if that one also works? Working? 6 working? Okay, we have 2 solutions. Now, in the past, whenever you've had an equation you solved, typically with an x like that, you got 1 solution. Now we're getting 2. Any thoughts to why we suddenly would have 2 solutions in terms of what that equation shows? What's new there that might be attributing to us having 2 solutions? Oh, the x squared. So maybe that squared gives us a different number of solutions. Okay. Now, the easy way to factor this is probably not going to be to sit there every time and just guess and check numbers. You guys have got 6 pretty quick. You maybe had a hint to where to go, but there's a faster way. So we need to figure out how to get these solutions there. Let's take what we've already done last week with multiplying. So what if this was where we ended up? How can we get to where we started? That's multiplication process we have. Let's reverse the multiplication process. What did I call it? The opposite of multiplication or distributive property. Factoring. So reverse that process, and what do we end up with? Can you fill in the box backwards with what we have there. X squared minus 2x minus 24 is our end result. We want to get to what would we put in the columns and the rows. Okay, let's start here. Let's see if someone can help us. What's a value I know would probably go in one of these boxes? X squared? Okay, where would x squared go in these boxes? Okay, usually went top left. What's another box we might know? Negative 24. Okay. Now, those middle boxes are usually where we did combine like terms, right? Okay. Let's look at our end product on the outside. I'm probably pretty certain that's going to be an x and an x. You agree with that? So really it's finding how can we get to multiply to negative 24 with these values out here. What do you want to try? I'm going to try negative 4 and what? Okay. That gives us negative 24. But does that make this work? That's going to be a 6x, a negative 4x. That comes out to be 2x. That's a problem. What do you want to flip? Negative 6, positive 4? Now it comes out to be negative 2x, which is what we wanted. So what we actually had up here was x minus 6 and x plus 4. So when reversing the idea of using multiplication, we can factor it to see that x squared minus 2x minus 24 is x minus 6, x plus 4. Okay? We'll put another one up there before we go further into a pattern and see if things are still working the same. Let's go x squared plus 5x plus 6. So if we went to reverse the multiplication of that, now I'm seeing x squareds and 6's here. That's good. I'm seeing x's here. And then some are trying to figure out how you get to 6, right? Multiply to 6, but we need to have the right terms. What do you want to put right here? Positive? Okay. Here? Okay. We got 3x. We got 2x. Combines to be 5x. So we could say that x squared plus 5x gives us x plus 2, x plus 3. Okay, it factored again. Now, the big picture we have here is we want to be able to later on have an equation like this and be able to find the solutions. The solutions we found in this case were 6 and -4. It required some guess and check. That'd be kind of a headache to have to do every single time, especially if the numbers weren't integers and close to 0. If your solutions were like 75 and -43, probably take a while guessing and checking. But we got down to a factored term. What's nice about that is when that is equal to 0, you can set each one of them equal to 0. We get the 6 and the -4. Notice they're the opposite signs. I'm not worried about this part right now. We need to first get that better step. We need to figure out a quicker way we can get down to this form, because here I know the solutions. This way it's guess and check. So we did another one. We got down to this. I think it's fair to say still kind of a headache to have to sit and look at taking these apart each time going backwards, especially when it's not numbers like 2 and 3, as values get bigger and bigger. So we want to find a shortcut. We want to find a pattern. What's going to help to make this process work each time? Thoughts?
Two numbers that add to the second term and multiply to the third term.
Talk about that second term?
Yeah.
So we've got to add there. And what?
Multiply.
Okay. Do the first one? Top one do that? -6, +4, add the -2. -6, or then they multiply to be -24. Okay? Let's go to x squared plus 16x plus 63. We want to see if our pattern holds up. So what are we looking for? Talk it out. What numbers that we want to add and multiply to? Add to what? There you go. Multiply 63. Okay, so I heard what? Does that work? Is that the only one that works? Is that the only way you could add up to 16 multiply to 63? Yeah, so there's our factors. We factored it down. If we needed to, we could then set those equal to 0 and find the solutions. So what our rule is going to be, and this is factoring, put this in the title, trinomials. And I'm going to put a little note where a equals 1. And that just means our lead coefficient is 1. Tomorrow we look at it when it's not. It'll be a different value. But we could say that x squared plus bx plus c. We have the sum and the product of what our factors would be. That's going to be the rule we're going to use. It comes from multiplication. It comes from a desire to quickly find the solutions whenever we're given, in this case, a polynomial. Now we just have to be careful with it, making sure we pick the correct terms. Positive 16, 63, not real difficult. We got positive numbers. But when negatives come up, we got to pay attention. Let's go here. X squared minus 12x plus 27. What do you think? If they're going to add to be negative, but multiply to be positive, the only way I get a positive with a negative involved has to be a negative and a negative. The order? No, doesn't matter. Okay, -9, -3. We agree? We multiply those two, we get a positive 27. You add, you get a negative 12. Okay, a hint there, if you have a positive product, positive multiplying, but a negative sum, they both have to be negative. Now, what if it was a positive 12? Would the 9 and 30 just become positive? Okay. What if it was a negative 27? Would that change things? Yeah, that'd be the difference. What about x squared plus 2x minus 63? What do you think? Plus 9 and? Okay, positive is bigger by 2. And then a negative product, we get negative 63. Okay, now, these are basic. Let's add a little more to it, but this key thing happens in the middle. Middle term, sum, last term product. What I can do is add some variables. We'll go new screen here. Hold on. Now to make sure we understand when we have two variables involved, I'm just going to draw that box again as if I'm multiplying. We still put the x squared in the top left. The negative 14y squared goes in the bottom right. We're still going to have to find that difference between the two terms. But notice the x's stay here. Now, I got to figure out what numbers go with the x's, but hopefully you really see it's now going to have a y attached to it. So it's going to be x plus or minus something y. So when that y squared shows up on the right-hand side, it just means it's part of the other term. We're still looking at sum, we're still looking at product. So I'm still looking at 5 and negative 14. What am I going to do? So if we did x plus 7y, I've got a 7xy here, and an x minus 2y, that's negative 2xy, still combines. So that factors again to be x plus 7y, x minus 2y. Okay, let's do that one. What do we want to try? 12 and negative 8? Okay, their sum is 4. 12 minus 8 gives us 4. Multiply and we do get negative 96. So we could get bigger factors. It then just comes down. If you have to list the factors off to the side, that's fine. By saying, hey, 96 is 1 and 96, 2 and 48, 3 and 32. And just keep going down. You can do that when the factors get bad and then start to match them up. Yeah. They're factors of it, but they're not 4 apart. So if it was 20, x, y, you would use that one. Okay. Let's give you the ugliest one I can find here. You guys look bored. We gotta challenge you here. Two x to the fourth plus 16x squared y squared plus 30y squared. Where's the first problem here? We haven't seen yet.
You can't add it and multiply it and do that thing. I have an idea.
Have we seen any with a 2 there?
No.
No, wasn't the name of the section factoring when a equals 1?
Yeah.
How do I get rid of a 2?
Dividing it, so do x to the second.
Factor out. It's the greatest common factor, guys. Greatest common factor. Take a 2 out of each term. Don't take anything else, because you don't have an x in every term. You don't have a y in every term. But taking a 2 out of every term, putting the 2 out in front, then makes it a little bit more familiar.
That's what's up. Link. Just be the number. Oh yeah, I saw that.
No idea what you're talking All right, let's give a little guidance here. What goes right here? It's not x. Yeah, it's going to be x squared. The other ones were x's because you had x squared. This is x squared squared. In order to get to that box that we had originally when we did multiplication, you have to do x squared, which means what's going to be those last terms with the y squared? Oops, something's wrong there. Let's go back and get rid of. One of them needs to be a fourth or a squared.
We have to write that too? Oh, good.
Hold on. Hold on. My mistake here. Okay. This needs to be a y. That's a y squared. Okay, if that's the case, these are y's. All right, I got ahead of myself. Now we're there. Okay, so we have this built-up problem we have to factor. We factor out our greatest common factor. That's taken care of. Don't forget the 2, it does come down. But then we have an x to the 4th. That gets taken care of with x squared. So this is a y squared. That gets taken care of there. Now it all comes back to the original thing we started with. What adds to 8 multiplies to 15? So we go 2 times x squared plus 5y times x squared plus 3y. That is the factored form. Down in the basics, there's nothing else that could be factored out. Tomorrow we'd have a little bit more. If we didn't factor out the 2, there may be something else we could factor. But that's where we go today. You should not be factoring anything with a number in front of the x squared.
What happened to the x squared after 8?
When you do the... you write it out. We got x squared plus 5y. This right here becomes 5x squared y. This becomes 3x squared y. So that x squared is just the, it's from like the combined terms. So it's kind of like how in this one I had an x and an x squared. It's, the x squared becomes the x's. That one just goes away. Yeah, factors to x minus 3, x minus 9. If you have to solve the equation, you'll see a little bit of these worked in towards the end of your assignment. What you're going to do from our zero product property, it says if one of the if the product equals 0, then you can set each value equal to 0. So you'd say x minus 3 equals 0, x minus 9 equals 0. So those would be your 2 solutions. Notice they're the opposite of the factors we had. Whereas x minus 3, x minus 9. You'd switch them in. If you had something like x squared minus 42x, what would you do to factor it? What's a common factor? X comes out. Then you can set each of them equal to 0. Say x equals 0, x minus 42 equals 0. You get those 2 solutions. Now, that is only when the equation is equal to 0. If it's just like the ones we started with, don't worry about that. You just factor it, leave it as the expression. If you look at your assignment for 1-3, 19 through 24 is when you'd solve it down to equal 0. So your assignment is course 1.3. Let's go 2 through 18 even. 19 through 25.